back to Generative Components and EcoSim Building Designer integration. In this session, we will be focusing on how modeling in GC differs from modeling in EcoSim Building Designer. I will give an overview of the differences in the interface, explain how to start populating the model with geometry, which in turn populates the graph. We will also learn how to populate the graph, which in turn populates the model, and how to record these transactions in the GC script. The GC interface is an extension of the EcoSim Building Designer interface. The tasks are expanded to include a Generative Components taskbar with the GC primary tools. In addition, you will have node types, transactions, and node properties docked along with the task. You still have up to 8 view windows for modeling. In addition, you will have a graph view, which is a diagrammatic representation of the model, indicating the relationship between elements or nodes, as we like to call them in GC. And finally, you have the transactions view. One of GC's strengths is that it is self-documenting. As you create geometry, GC records the steps required to create the geometry in a series of transactions. The transactions can then be unplayed, replayed, edited, and rearranged to change the manner in which the model is built. So let's start with the primary tools. The primary tools allow quick access to basic functions. We often start here, placing our first point or coordinate system. So we'll start by placing a coordinate system. GC models do require a base coordinate system in order to locate X, Y, and Z points in the model. So that creates a coordinate system in the model at the global origin. It also creates a node on the graph, and then we record that transaction in our script. Once we have a coordinate system, we can start placing other geometry, for instance, points. As we place a point in the model, it creates a node on the graph. The graph records the relationship between the elements in the model. So those points have a relationship to the base coordinate system because it's using those X, Y, Z coordinates. We can also move and modify elements from the primary toolbars. So we can grab a point. Notice that the points have various handles. This determines the direction the point will move. If you select one of the axis handles, then it's going to move along that axis. If you select one of the plane handles, you'll be moving the point along that plane. And again, once we've finished, we record the transaction in the script. Most of the geometry you create in GC, however, will not be placed directly in the model from the primary toolbar, but rather placed as nodes on the graph. So the node is a central concept to GC. It's also a bit strange if you've never worked with nodes before. The GC workflow requires you to construct the model from a number of small elements or nodes. For instance, a line is constructed by first creating 2 points. A polygon can be created from a set of lines, and a solid created by extruding the polygon. A change to the original points will dynamically flow downstream and change the solid. Nodes are the building blocks of a GC model. So nodes can be geometry such as a line, or curve, or a point. When GC is run as an extension of EcoSim Building Designer, there are nodes for BIM objects, such as walls, doors, and windows, structural members, and floors and spaces. Nodes can also be data, such as a slider to control a variable, such as a length. The dependencies between the nodes and inputs are retained and visible in the graph view. So to place a node on the graph, you simply drag and drop from the Nodes Types palette onto the graph. So we select the node that we want to create. For instance, we'll select an arc here. We can drag and drop or simply click and it will show up on the graph. And the first step is to give the node a meaningful name. So we just click in the top field and we rename the node. So as you create objects in GC, you can give them a unique name. GC will do this automatically for you by giving the object the name of its type along with a number. For instance, point 01, line 01. You can, and in many cases should, give objects meaningful names of their own, following a few simple rules. The name must begin with a letter. It may not contain spaces. And names are case sensitive. A common practice is to join words together without spaces, called camel case. For example, arc base, number of beams. All nodes have various techniques that can be used to create their geometry. There are many ways to create an arc, for instance. So the second step is to determine the technique. We can select from a pick list here. As we hover over each technique, it will tell us the inputs required to use that technique. So for instance, if we select the technique by point on curve, we need 3 points: a start point, a point on the curve, and an end point. Now you'll note this node is still under construction or incomplete because so far we have not given it the inputs. We have not determined which points will be the start point, the point on the curve, or the end point. Now which technique you choose depends upon what inputs are available. It may also depend upon the design intent, as each technique makes a node behave differently. In this case, we used by points on curve, which required a start point, a point on the curve, and an end point. And we had placed 3 points, and we wanted to be able to use those points to control the position of the arc. If I had wanted to control the radius of the arc, I would have probably placed a point to use as a center and used a different technique. Once you've selected the technique, you have to provide the inputs. So to provide the inputs, we can simply link up one node to another node. So we can link 0.01 to the start point, 0.02 to the point on the curve, and 0.03 to the end point. Once all the inputs have been fulfilled, then the geometry will be created. And there's now a relationship between the points and the arc. Now, in some cases, inputs may actually require an expression, such as a numeric value or an arithmetic expression or even a variable. The expression input fields are similar to an Excel input field. You can type in simple numbers such as 5, or an arithmetic expression such as 5 plus 2, or use the property of another node such as the length of the arc base divided by 20, or a function like the square root of another value, or a variable that may have been established previously, like glass width. However, each field will only accept the correct type of data. There are 4 data types: an integer or a whole number, a double or a real number, a text string, which must always be in quotes, or a Boolean, which would be something that requires a true-false. And finally, it could be a GC type, so GC has a number of types such as a point or a curve, and if you hover your cursor over the property, a balloon will indicate the data type required. So as you can see here, if we're going to add some additional points by spacing them along our curve, we can link the curve as an input, but the spacing has to be put in as a value. So we could put in a value of 5, for instance. And then we have some other inputs as well. These are optional, but for instance, whether that spacing is determined by the chord length or the arc length, and whether or not they will be equally spaced. You can see these are Boolean type inputs, meaning they're true or false. Now, once some base construction geometry has been created, then the real fun begins, adding BIM elements with the Ecosim Building Designer nodes. So we can scroll down and use the Ecosim Building Designer nodes and, for instance, select a wall node. Places a wall node on our graph. We could rename it. We'll call it wall, curtain wall. This will be our curtain wall, CW. And we want a technique, so we'll select linear by points. We have a series of points that we've placed along the arc. And then we can simply select a catalog item. So note we have our same catalog dataset that we have in Ecosim. All our walls are available, including any project walls you might have created. So we're going to select a curtain wall type here. We'll link up the points to our point base node, and then our curtain wall is created. Now again, if we go and look at the node properties, there are other properties we could set, including all the data group properties that exist on that wall type. But for instance, I could set the height of the wall, so I could change the wall height here to 14 feet. But we could put other properties as well. For instance, maybe we want to put the phasing, and we could type in new construction. Note, this is a text string, so it's going to be in quotes, and we'll type in new construction and record those transactions in our script. So remember, each BIM node has a catalog type from the data group system. All the data group properties are available as inputs. The data group information is tracked in the Data Group Explorer. And finally, we also have utility nodes. Utility nodes could be used to control a variable, such as a slider or a log curve. Could be used to import and export data, such as reading and writing to Excel. Might be used to control a process, such as adding a camera to the model or attaching a reference, or to evaluate other nodes by placing a watch or a gauge on them. So for example, a slider could be used to control a variable like the height of the wall. So we could create a slider node by selecting it from our utility nodes and drag and drop it into the graph, and then rename it so that we know what it's a variable for. So we might just call it height. And then we have to give it a range. What's the range of the values that we're going to accept there? So I might say the minimum is 10 feet. And the maximum is 20 feet. I can put in a resolution. So for instance, maybe it's 0.25. Then I can actually turn on an option to snap to the ticks. So these are the ticks that are on the node, and I can give an interval to those ticks. So perhaps 0.5. And then as I slide the slider, it snaps to those tick points. And in that way, we could adjust very quickly the height of the wall. Of course, we have to link that variable to our wall height property. So I'm going to pin the height property to the node so that we can see it, and then I'll simply link it to our height node. And you can see as soon as I did that, it adjusted the height of the wall. And now I can move the slider and adjust the height of the wall. However, you'll notice now that we have all this geometry connected to that variable, it's a little hard to move the slider because it's trying to update the geometry as we do it. So we do have an option on the curtain wall node. We can turn on what's called deferred dynamics. So that means it basically defers any changes to this node until we're finished adjusting another node. We can now freely move the slider to the height that we want. Once we settle on a height, then the node or the geometry changes height. So let's review. So we've got a slider that's controlling the height of our curtain wall. If we open our Data Group Explorer and expand our wall and curtain wall schedule, you can see each panel of the curtain wall there is listed in the Data Group Explorer. It has its height and its length. Remember, we put our spacing at 5 feet, so it's as close to 5 feet as it could to equally space along the arc. And if I were to move any of those initial points we placed, everything moves downstream. That adjusts the arc, that adjusts the number of points along the arc, and that then adjusts our curtain wall. And if I refresh my Data Group Explorer, I will see that I now have fewer panels. They have a different length. And once again, if I refresh again, fewer panels, a different length. Everything is being adjusted dynamically. But I have all the data in the Data Group Explorer. So you should now have a basic understanding of how to begin modeling in GC. Next, you will want to begin to understand some basic principles of computational design, like parameter space and t-values, lists and replication, and the series function.